Ever wonder how AI creates stunning images or videos from scratch? It's like magic, but actually it's rooted in some pretty clever math. Today, we're diving into a fascinating new approach to generative AI, one that borrows ideas from physics, specifically the world of active matter. So, what's a generative diffusion model? Think of it as an AI that learns the rules of a data distribution, like the patterns in a dataset of cat photos. Then it generates new, realistic images by starting with random noise and gradually refining it. The key, a process called diffusion, where noise is added and then reversed, like undoing a painting's smudge. But here's the twist. Most models use a score function, a mathematical guide that tells the AI how to adjust its guesses. Traditionally, this score function acts on the velocity of particles in the model. But what if we could skip the velocity and instead use a force field that directly shapes the particles' positions? That's exactly what this research explores. Imagine particles that move on their own, like tiny robots or bacteria. These are active particles, and they have a memory of their movement, what physicists call persistence time. The study shows that by applying a time-dependent effective potential, think of it as a dynamic force field, directly to the particles' positions, we can still generate high-quality data. This is a big deal because it simplifies the model and opens the door to real-world experiments. Here's the cool part. Instead of tweaking the particles' speed, their velocity, we can use tools like optical tweezers to physically nudge them into place. It's like using a remote control to steer tiny particles, rather than guessing their movements. The math behind this, it's based on approximations from physics, like the Fox approximation, which helps translate complex particle behavior into something AI can use. The results? Numerical experiments show this method works. By focusing on position rather than velocity, the model maintains accuracy while being easier to implement in physical systems. This could revolutionize not just AI, but also how we study active matter in labs. Think of simulating cell movement or designing self-assembling materials. So what does this mean for the future? It's a reminder that AI isn't just about algorithms, it's about borrowing ideas from the natural world. By merging physics and machine learning, we're unlocking new ways to create, understand, and even build the world around us. Next time you see an AI-generated image, remember, it's not just math. It's a dance between science, creativity, and a little bit of active matter magic. Thanks for watching, stay curious.